Hello, you are welcome. In this video, we are going to solve this exponential problem. This is n to the power of 3 equals 8. Now we are solving for all values of n, and let's go ahead and do that. So what we are going to do is we are going to start by expressing this 8 here in its exponential form. And you can express it in its exponential form using 2. So 8 is just 2 times 2 times 2. And that means this is 2 to the power of 3 and this is 8. You have n power 3 equals 2 power 3. Now observe the exponent are the same. And since the exponents are the same, you can easily say that n equals 2. This is just one of the solutions. This is n1. Because if you have a power c equals b power c, the two c's are the same. That means a equals b. So n equals 2 is just one of the solutions. Now, how do you solve for all the values of n when you have n power 3 equals to power 3? Both the real and the complex solution, because this is just the real solution. Now, to solve the real and the complex values of n, you simply move this over here. You have n power 3 minus 2 power 3, and this equals 0. So we need to expand this. This is to the power of 3, this to the power of 3. If you have a power 3 minus b power 3, this equals a minus b times a squared plus ab plus b to the power of 2. So right now, your a is n, while your b is 2. Alright, so we need to insert this n and b and 2 for b respectively. A minus b will be n minus 2 times a squared will be n squared plus ab will be n times 2 plus b squared will be 2 squared, and this equals 0. After doing that, I will have n minus 2 times this is n squared plus n times 2, that is 2n plus 2 power 2, that is 4, and this equals 0. So after doing this, I need to equate each of these to 0. I'll have n minus 2 equals 0, and also have n squared plus 2n plus 4 equals 0. So it's time to solve these individual equations, starting with this one here. That means I can solve this linear equation by moving -2 over here. I'll have n equals 2. That's my n1. Now to solve this quadratic equation, I need to make use of the formula method. If you observe very well, the 2 is exactly what we had earlier on when we were using this method of comparing the exponents, because they are the same that. So we need to solve this quadratic equation. So let me recopy it here. I have n squared plus 2n plus 4 equals 0. So let's solve using the formula method. I write the formula in respect to n. I have n equals negative b plus or minus square root of b squared minus 4 times ac divided by 2a. So at this particular point in time, we need to find out what is a, b, and c, and a is the coefficient of n squared, that is 1. B is the coefficient of n, that is the 2. And c is the constant, that is the 4. So let's insert everything right here and make use of the formula. We have n equals negative b. This is 2 plus or minus square root of b squared. 2 to the power of 2 times 4 times 1 times 4 divided by 2 times a, that is 2 times 1. Now, having done that, I need to simplify this. So we are going to have n equals negative 2 plus or minus square root of, this is 4 minus 16 divided by 2. 4 minus 16 is negative 12. I have n equals negative 2 plus or minus square root of negative 12 divided by 2. And from here, I have n equals negative 2 plus or minus, this is square root of negative 1 times square root of 12 divided by 2. So, as you can see, square root of negative 1 here is I. I have n equals negative 2 plus or minus I times square root of 12 divided by 2. From here, I have n equals negative 2 plus or minus I times this 12 here. This is 4 times 3 divided by 2. So from here, I have n equals negative 2 plus or minus I times this is square root of 4 times square root of 3 divided by 2. So from here, I have n equals negative 2 plus or minus I times square root of 4 is 2. And this is root 3 divided by 2. The 2 cancel the 2 cancel the 2. We have n equals negative 1 plus or minus I times root 3. So these are the complex values for n. They are actually 2 because we have both the positive and the negative value. So I can have my n2 is negative 1 plus I times root 3. Why I'm writing n2 here is because I've already gotten my n1. And my n3 equals negative 1 minus I times root 3. So these are the two values, complex values for n. Meanwhile, we have already gotten our real value for n, which is 2. You can also decide to insert this value for n here. All you do is to check. You have your n equals 2 and n power 3 equals 8. So you have 2 to the power of 3 equals 8. And 2 to the power of 3 here is 2 times 2, 2 times 2 times 2 equals 8. And 2 times this for 4 times 2 is 8. You simply have 8 equals 8. Alright, so you can as well check using the complex values. Most time I've not been checking using the complex values. Maybe I will try and be doing it, but it's going to take a lot of time. So I don't want the video to be too long. You can check using the complex values, but remember, if you want to make use of complex values, the square root of negative 1 equals I, meaning negative 1 equals I to the power of 2. This will actually help you in order to manipulate your ways and getting it right. So that is it. Thank you and goodbye.